Okay, well, I hope you guys are all excited. This is a topic that I'm personally really interested in. It's a topic that I've actually just learned a ton about because I just got back from the RStudio conference that was held down in Austin, Texas last weekend. And one of the big topics there was Shiny and how Shiny can be used in production. So I want to talk about R in production. I also want to let you guys know that this topic really relates very well to what we're doing at Business Science University. As you'll see towards the end of this, talk, we're going to be showing you how we have plans to totally integrate all of the new tools and show you guys how and teach you how to build production style apps, ones that you're going to have no problem scaling up to lots of users. So with that said, this is R in production, building production quality apps with Shiny. You guys ready to get started?
Let's get started.
All right, let's do it. All right, so just real quick, this is the structure of the Learning Lab. We'll take about 30 minutes and just do kind of a nonstop presentation where David and I give you guys lots of learning tips, advice, resources, and help in any way that we can. And then at the end, what we'll have is probably about 15 minutes for Q&A. So I'm Matt Dancho. I'm the founder of Business Science. David, do you want to introduce yourself?
Sure. David Curry, founder of Sure Optimize. We do search engine optimization and marketing analytics.
Cool. All right. So let's get started. Here's the agenda for today, guys. What we're going to be talking about is first R in production. I'm going to do a demo of the app that we're building for the 300 series course. And then I'm going to talk about new tools that we just found out about and we learned about through the RStudio conference last week. These are really powerful tools that are going to totally enable you to take your data science apps to the next level. Mm-hmm. We're also going to talk about why production, and we'll go through a business case. And then the third point there, we're going to go through a workflow for business value. And then what we'll do is we'll wrap up with an accelerated learning plan to get you started. Okay, so R in production. And this is one of like the biggest things where there's a lot of myths out there. You hear people say like, oh, R can't go into production. You have to use Python for production. That is definitely not the case. And I know David and I were chatting before the talk. He's got experience. I've got experience. You can use Shiny in production. You can use it for both pieces of client-facing apps, or you can also use it for internally facing apps where you don't have to have authorization to get access to it, and it works really well. So when we're talking about R in production, the first thing that we need to answer is, what is production? What does that even mean? And I know there's a lot of, kind of things out there that people think it means. To us, what it means is putting a data science product in the hands of decision makers. Mm-hmm. So that is the ultimate goal for us as data scientists. You're not generating business value unless you're influencing decision making. So you need to be able to go into production. So that's why RStudio developed this tool. It's called Shiny. And what Shiny does is it's a web framework that allows us to build these web apps that can go into the hands of decision makers. So basically, it enables you to take your data science and go into production by influencing the decisions that these key decision makers are making every day.
Yeah, and this is really cool because as a data scientist, you'll likely be working in a data group. You guys will deliver models and solutions to problems, and you need a way to package that and allow decision makers to use your result, your model, within their own workflow. So if you're an executive or if you are a director of a particular department, you don't want to have to call up the data group every time you need a piece of information. So moving into production can be either internally facing, where you're delivering your solutions to people within the organization, or it can be externally facing, or both. But externally facing means folks from outside of the business are accessing the model. So production can be different depending on your job and the type of work that you're doing. But ultimately, it's a way to package a solution so that other people can interact with it and have a single source to access it.
Right. It's think of it this way. You're making all these algorithms that generate predictions. You want to be able to use those predictions and make recommendations off of those to be able to influence the decision maker's ability to do their job better. So your goal is to actually not make the decisions for them, but to give them data and give them insights that they can then use to save the company money or gain more customers.
Mm-hmm.
You know, those are the goals.
Yeah, there's one more thing I want to add to this, Matt, is that most likely there will also be a developer group in your organization, your business. But the cool thing about Shiny is it allows you to quickly create a simple web app within your own group, so you don't have to rely on another department. Whenever you have to go to another department, you have to basically rely on their own schedule and their delivery schedule. But this gives you the power to deliver your own solutions and within your own timeline, and it can just be part of your workflow, which is really cool.
Yeah, there's huge demand for this technology. I can tell you that right now. All right, so this is the app that I just demoed at our studio conference last week, and it's the one that we're building for our 300 series course in the art track. So I'm going to show you guys it right now. What it is here is a web-based tool that implements machine learning. It implements Lime for feature explanations. It implements a lot of data science underneath the hood. But the nice thing is that the people who need to make these decisions, they don't really care about any of that technology. What they want is they want the output. So, for example, what this app does is it detects employee attrition, the risk or the likelihood that an employee is going to leave a company, and then what it does is it tells the manager, hey, how high is that risk, and what are the most important features, and what do we recommend that you do in order to be able to reduce the chance of that person from leaving the company. So, for example, if you click down here, we've got different employees. So I just clicked on 891, and this particular employee has a high prediction risk of 47%. The font is now red, indicating that this person is likely to leave. And then we've got the features here that are related to why that person is either likely or not likely to leave. So for this particular employee, stock options is one of the reasons that this person could potentially be put in a high risk category. Right now, they're not receiving stock options. So from a manager's perspective, maybe what they can do is come up with a strategy to get that person to gain, some stock options during their next, performance review or something to that effect. So it really enables them to develop strategies. It also provides them some strategies here. For example, the logic that we have baked into this app, it's telling that manager that maybe one work environment strategy is to promote job engagement. And these are the high risk features that you could probably adjust to help promote that engagement. So the key thing here is that Shiny allows you to take your data science that you did with the building machine learning models, which develop a prediction risk, building feature explanations, building recommendation algorithms, which you can see here, and package it into a nice solution that business people can interact with. Okay, so that's the app, and really the benefit. Whoops, I lost my. Where are we here? There we go. Everyone can see my screen now, right? You can see it, David?
Yes, good to go.
Cool. So that was the app, and you notice that it seemed to interact pretty easily. There wasn't much lag time in it. There wasn't, many issues. I mean, I'm the only user that's in it right now, but it seemed to be working properly. One of the issues that comes across out there when you talk about R in production is that there's not a whole lot of tooling out there to be able to debug and test for these application style issues that you run into. So this question came up: can Shiny be used for production? And back in 2015, Joe Chang, he's the CTO at RStudio, he said that the answer is yes, it's quite possible. Well, fast forward 4 years, and now what his answer is yes, and it's quite easy. So basically what he's done and what RStudio has done is they've developed a ton of tools that really are just able to help take us to the next level as we develop these applications. So this is another photo from his keynote speech. He's got a whole list of tools. I'm going to focus on just a few of them, these three here: Shinytest, Shinyloadtest, and Profvis. So these are three tools that will help you be able to, once you've developed your app, be able to test them to make sure that they're integrating properly and making sure that they can scale up to the number of users that you want them to go to. So the first one is Shinytest. And what this helps you do is integration testing. And as your app evolves over time, it allows you to use this thing called an event recorder. And if you're familiar with Excel, if you've ever done macros where you've recorded in Excel like what your actions are, that's kind of how this works. You have an event recorder. So as you're playing around with your app, clicking on different things, entering in different user input, what it does is it keeps track of all that. And then over time, it tells you what is different and if there are any breaking changes. So this is basically answering the question, what has broken as your app has evolved, and how do you fix that? So that's the first package, Shinytest. The next one is Shinyloadtest. So this one is for answering the question, how well does your application scale? So you can see here, this is the output of a Shinyloadtest report, and each of these is simulating different users. So you can simulate as many users as you want, and what it'll do is kind of like a cannon blast, just pound your application with a bunch of simulated users and basically track what's happening in the app and how much latency there is between actions, such as like building plots and generating reactive inputs. So there's different colors here too. So you can see that there's the home page, there's a JavaScript, there's the start of the session, there's calculations. So you can see if there's long latency with some of these actions. And then the next one, which is really cool, is Profvis. So these two kind of work in tandem. So Shinyloadtest tells you if there is a problem, and then Profvis allows you to analyze how efficient your code is, telling you where that problem exists. So this is really cool. All you do is you wrap your code in this Profvis function, and it generates a flame graph that shows you which are the most expensive pieces of your code, and actually gives you the amount of time that it took to run that piece. So what they've developed is a really robust set of tools that enables us to really test out and prove out that our application is prepared for production. Okay, and then the last thing here, this is what Joe Chang also showed at RStudio conference. This is kind of like the step-by-step process. So you use Shinyloadtest first to see if it's fast enough. Then you use Profvis to see what's making it slow if it's not fast enough. Then you optimize. You can move work out of Shiny, which is very often what you need to do. So you can move calculations being performed in the app to the server, or you can pre-process them overnight with a batch script. You can make the code even faster, which is maybe using like packages like RCPP for C++, or just trying to, instead of doing for loops, which tend to be expensive, trying to vectorize operations and so on. So it's kind of this process that you build where you really, you build a functioning app first, and then you improve it repetitively to get it optimized. All right. Any questions so far, David?
Yeah, we got a couple. So there was one, we talked a little bit about about scale. Excuse me. But I guess the question is how well does Shiny scale? Are we talking 15, 20 users, or are we talking something that can work with thousands of users?
People have scaled it to upwards of thousands of concurrent users. And again, there may be like special tools, like it's that optimization path that you have to go through, but it's definitely possible. So
Yeah.
Yep.
Yeah, and I think a lot of it also has to do with your implementation. How are you hosting it and all that good stuff.
Right.
Your
Yep.
infrastructure, that is.
Yep.
And then I guess that also leads into cost for implementation. I'm assuming Shiny is open source. So like, what are the licenses? Are there server licenses? How does that part work?
Yeah, there's actually a free version of the Shiny server, which is what's used to run Shiny. And then there's a professional grade version. And I'm not exactly sure like what all the bells and whistles are with the professional grade, but both are out there. So you technically can probably get it done without a license.
Yeah.
Okay.
Okay. So that's good for now.
Okay, so let's get into answering this question, why production? Why do we want to go into production even in the first place? So the reason is because production is how you save your organization money. So for example, a very important problem that has a lot of zeros behind it, meaning it's a high dollar financial problem to your organization, things like customer churn or all sorts of different like large scale problems. Just simple changes can often generate millions of dollars in return for your company. And if you can prove that, and if you can show that to your company, you're probably getting promoted, number one. But number two, it essentially funds your group for years and years and years. So really, data scientists are in this unique position to be able to solve these big scale problems with data. And that's really why you want to go into production. You can't solve any of these problems until you go into production because you're not changing anyone's behavior. So that's really why we need to get to production. Here's just a quick case study. So one example, which is what we teach in our course, is employee churn. And it's a simple calculation. It turns out like if a company is losing high performers, it's $78,000 per employee on average. So if an organization loses 200 of those employees, that's very quickly a large problem. It's $15 million per year problem for that particular organization. So if you can even reduce it a few percentage points, then you're saving your company a lot of money, and that's recurring revenue too. So that's revenue that your group has continuously generated for that organization. All right, so the key here is that you only generate business value when you change or influence decision making. So you can be the best data scientist ever, but if you never go into production, then you've never helped that organization because you aren't generating any value to the company. You're not changing the decision making process. Mm-hmm. So it's this cause and effect relationship. That Shiny app is really the vehicle that allows this better decision-making effect to happen. So what we can see over here is we've got the Shiny app and you've got the arrow that points to monitoring the impact of decision-making improvements. When you release the app, you're up here, and this is employee churn. So your company is losing 20% per year of high performers. And then by the end of that year, they're at 9%. So what you can see is that the cumulative savings is adding up, and then all of a sudden you're at $4.3 million at the end of that year. You've just saved the company. So that's the power of going into production.
Mm-hmm. Let me just jump in really quick. Mm-hmm. We have a question from Steven. One of the biggest challenges in implementing production, getting buy-in from users as it is a new way of working. From your experience with Shiny, what are some factors to consider when developing a Shiny application to get user engagement?
Yeah.
If I could just jump in on this one. Mm-hmm. So I have like 20 years of software development experience and management, even at the executive level. And I would say that this is a culture thing, and it's about any type of new technology. And the hard thing about data science is it's sort of mystic to most people. They don't get it. It's a big black box, and a lot of the organization will even wonder why are we even bothering? So that's why one of the things Matt and I really focus on is delivering business value, which, you know, Matt's about to go into now. But you want to tie in the deliverable, whatever it is you're putting into production. You want to tie that in back to the objective, and show how you're going to save money or save time based on whatever your model produces. And typically it'll be in small steps. So it's not like you come out the gate with a full blown, big system, but it's more about understanding, okay, who is this, who's the end user, and why do they need it? And what does their workflow look like? And then trying to deliver something that fits very easily within their workflow so that you can get a quick win and then build on that. Because it's, if you can do small wins with people, then they talk about you, they talk about how great it is. And, the buy-in actually helps with that. So that would be my 2 cents.
Right. Yeah, I definitely agree with everything, David, that you're saying. The culture and the willingness to change. So that's what it comes down to, is change management, in my opinion. You have to, change management is never an easy thing. Most organizations hate change. And it's one of these things that if you try and force something down their throats, they're going to resent that. But if it comes off as you're just trying to help them, take their already good capabilities and raise them to the next level and help them get, who wouldn't want to, perform better? Meaning that a manager, if they're, if they're judged based on how well they're retaining their employees and they're retaining them even better, then that's a win for them. So it's really finding that common ground. It's involving stakeholders up front, and it's really trying to develop applications that aren't just an extra layer of work, but really fit nicely into that workflow that they already have already, as David had said, and making quick wins. I think that's really key in what David had said.
Okay, we'll save the other questions for a little later. Let's get through the business value, because I think this is important.
Yeah, this is really good. Yeah. So this is kind of like the whole workflow from going from business problem to business value. And this is something that is really important. It's really, we all need to understand this as data scientists, that this is the process that you will end up going through. You start with preparation, acquiring data, and formatting and cleaning it. Then, and at that stage, you're doing a little bit of learning about what's available to you. You get into the experimentation stage. That's where that's where the science comes in. You're developing your hypotheses. You're often visualizing the data. You're often redetermining hypotheses as you're visualizing and transforming data. And then you get into modeling. And then you find out that it's an iterative approach, because oftentimes your model isn't quite where it needs to be. You need to either go back, collect new data, or refine your hypotheses. And then eventually you get to that point where you're ready to communicate the results. And that involves business reporting, that involves executive buy-in, that involves stakeholder buy-in. And then also at that point, once they give you the green light, then you're ready to go into deployment, which is developing the applications and making tools that are going to actually generate the business a return on their investment. So that's where you get the business value out of. So the nice thing about R is they have a complete tool chain to help you do all of this. So you can see here that this is where all of the different packages that are open source can be implemented within your workflow. You can see over here, you've got a lot of the reading packages, and then the data manipulation and working with text, time series, categorical data, more data manipulation and visualization packages. Then you've got the machine learning, the heavyweights here, the ones that everyone wants to learn, and quite often most people jump into them too quickly. And then you've got per to help with iteration and exploring different alternatives. And then you get into your production, you're developing reports with R Markdown, and then we've got the topic for today, which is deploying web apps, which is Shiny. So we've got this really comprehensive tool chain, and you can see it's kind of organized. You got the basics here, you got the machine learning, and then you got the apps. So what we want to do is we really want to make it as efficient as possible to kind of come through this workflow and generate the business value, which is these apps that integrate all of the different data science that you've kind of learned and packaged up. So this app integrates the algorithm from H2O, the feature explanations from Lime, the data manipulations from dplyr, all under the hood, that allows you then to generate business value. And then you got to monitor that value once you've deployed your app and once you've trained people on how to use it. And then you should get graphs that look like this. So I can't emphasize this enough. This is the money slide. So if you're taking your screenshots, right now is when you want to do it. So I'll give you a couple seconds. David, we got any more questions on?
Yeah, can Shiny be deployed on a personal server? Or
yes.
do I need a license for using the software? That's basically, is there an open source version?
Yeah, if you go on RStudio's website, they have the Shiny server, and I think that's all you'll need to download. It's free. It's open source, and then they have a pro version, which is a paid version. That's kind of like enterprise level.
Okay.
All right, we're going to continue on. So that's the data science workflow. How does this look like in a real problem? So this is what we're going to go through now, this case study. It's, again, the employee attrition. So that web app that we built, this is kind of like where you start. So you've got dplyr, which is at the beginning. So, and this is good for sizing the business problem. As you can see here, we've got some code. We're taking a data frame. We're counting some information up. We're converting those counts to percentages. We're assessing the attrition level with a custom function we've developed, and then we're calculating the cost of attrition. And then what's output here is by job role and department. We can see what the attrition level is in terms of number of people, and then the percentage of people, and if it's above the industry average or not, and that total cost of attrition that we've calculated using this function here.
Hey, Matt, can you talk quickly about, so this particular business problem, employee turnover or employee churn, how did you determine the size of the problem, the value?
So that comes from that cost calculation that we showed earlier on in the presentation when we calculated, like, it was $78,000 per employee. Mm-hmm. So there's a lot of different variables in there, but you can adjust it by salary. So basically, just run that calculation that I showed previously, and you can calculate it for on an individual level, at a department level, and so on.
Got it.
Good question. All right, so that's dplyr in a nutshell. Then what you can do is you can take the output of that dplyr and convert it into a nice visualization. So visuals are quick wins. You put these in reports. This is a static one built with ggplot2. And it quickly shows which are the key departments that we need to hone in on, and also the key job roles that can help to reduce that cost of attrition. So for example, sales executive, this particular company attrition is costing them $3.92 million per year in sales executives leaving. So an executive sees that, and the first instinct is going to be, all right, we better focus on sales exec. We should probably focus on lab technicians and research scientists. And if we can find out what's going on in those departments and fix it, we're going to save a lot of money. Mm-hmm. So that's even before we do data science. This is just descriptive analytics right here. Then you get into the high-end stuff. You've got H2O, which is great for machine learning. This is going to give you what is the percentage likelihood of that employee leaving. And it's really easy to use. This is the code. This is all you have to do to run automated machine learning. And what it does is it builds you a lot of different models. Right here, there's 20 models in this particular output, and it's got GLMs, gradient boosted machines, deep learning models, stacked ensembles, which is what it kind of groups all together, all the different models, and comes up with what's called a super learner. So H2O, fantastic package. That's where you're going to be generating the percentage likelihood and getting a nice model. And then once you got that really good model, you need to explain what's going on. So you can use this other package called Lime. And this is the code here. All it does is it takes that model that you've made from the AutoML leader, which is your automated machine learning, and then it converts it into a plot like this that shows you, okay, for that specific employee, what are the particular features that are affecting that employee's prediction the most. For this particular employee, they're categorized as overtime equals yes, meaning they're working a lot of overtime. Their number of companies that they worked at is greater than 4, so they're at a higher risk level of leaving. And their job level is 1, so they're lower on the food chain. So this is the type of analysis that you get out of the tools, but you still need to package that into a system that you can deploy to the business leaders. So that's what this is. That's what Shiny does, is it enables you to have that prediction in there. You've got the Lime feature plot here, and you've got dplyr and all sorts of other packages running under the hood. And that's what Shiny does for you. And then at the end of it, you monitor your impact, and you determine exactly how much you're saving that company, and you put it into a nice report that goes to your boss. And if you've saved your company a lot of money, you get promoted at the end of the year. And you can see that very easily, if you go from 20% attrition to 9% attrition, that is a $4.3 million per year savings. So at the end of the year, you put that on your performance review, and you're probably going to be promoted. All right, so again, this is the workflow. This is the path to business value. This is how you get there. And I just really want to emphasize that this is a good slide that shows you what you need to do in order to be able to get to that solution. Okay. All right. Any more questions, David, before we get to?
Yeah, we got a bunch, but let's just slip in maybe 2, and then we'll save the rest for the end.
All right, let's do it.
So since we just talked about AutoML, what are the pros and cons of automated machine learning from Monica?
Oh, that's a good question. So H2O automated machine learning is what I use almost exclusively. I have found that it helps me get to really good models faster, but they're not necessarily perfect. You can't just run with it. So you really have to understand how those models are working. For example, if you get a deep learning model, chances are it's going to be highly tuned to that particular problem, and it may not generalize well to future problems. So you really need to test those out. And if you're not watching out and you just run with it, you can get yourself into a bind. So I think the big thing is just understanding that it helps us do our jobs faster, but at the expense of you still need to know how the algorithms work, what results you're getting, and you still need to know how to validate that they are good results and they're going to generalize well to new populations.
Okay, and then one more real quick. I can answer this one. Production security. How do I deploy Shiny and protect my data assets? I actually just looked this up, and Shiny does have Shiny deploys in its own environment, and it does have an authentication, so you can have logins for it as well.
Yeah, and I know a lot of people are using like RStudio Connect, which makes it really easy to have push button deployment, and you can have logins and authentication. That is a paid product, but I'm sure there are other ways to either have standalone Shiny apps or even include the Shiny apps as kind of components, modules within a larger app that has a more secure infrastructure.
Yeah. And then really quick, just last, Valerio, usually a condition for software to be in production is to ensure service continuity. assistance and security? Who grants for that? I think that's sort of dependent on your business environment. Some things may go through the IT department. If you're in a data group, maybe they will allow you to do that type of thing. So that might be specific to your particular situation. But there are a few other questions. We're going to save those for the end because I think we're almost through the slides now.
Okay, cool. So the last thing here is, all right, how do we get to production? And so this is the goal. We want to be able to get to Shiny, building a Shiny web app and deploying that within our business, right? It's kind of like a hill climb. So when you start learning R, you start at the basics, you learn data cleaning and manipulation, and these are the packages that you focus in on. Then you get to visualization. You start working with functional programming and modeling. And before you know it, you're kind of scaling the hill, getting into advanced machine learning, learning things like H2O, Lime, and then you get to the top and you're in that kind of deploying stage, which is building reports and also building Shiny web apps. So, this is kind of the path, but there are a few kind of hurdles that you can go into. And one of the biggest ones is that last mile. So actually getting from that point where you're at machine learning to get to Shiny, that's actually a big hurdle. Mm-hmm. And the reason is because you need to learn a lot of technologies in order to be able to build a Shiny web app. First of all, you got to learn Shiny. You should also have learned HTML and CSS by now. And these are a lot of topics that traditionally data scientists may not be trained up on. Then you also have to learn about testing the app. How do you build not only an app, but how do you get it to production quality? And that's using things like Profvis, like Shinytest, Shinyloadtest. And only then once you've built and iterated through that app, have you achieved what we're going to call a production quality application. So that's the key here, is that, the hurdle, the mountain climb can be a little bit challenging. And it's because there's just so many things that we have to learn, not just machine learning, not just foundations, but also how to build applications and build high performing applications. So it can be quite overwhelming and it can take a long time if you don't do it efficiently. So here's the scoop though. What we're doing at Business Science University is trying to build a program that is as efficient as possible. So we found that you can actually get to the top of this hill very fast. So here's the plan. In order to get there, what we've developed is 3 different courses. The first course is in the foundation. So if you're starting at square one, meaning you don't really have a whole lot of experience with data science, then this is the course for you. So you will learn data cleaning and manipulation, visualization, functional programming, and even business reporting, all while you follow this ultimate cheat sheet and apply it to 2 different business projects. That one takes about 7 weeks to complete, and it's great for foundations. Then once you're ready to move into the intermediate to advanced data science, that's what this course is for. Business data science for business with R. It's the 201 series course. We teach machine learning and business consulting. We do advanced data science with data wrangling, advanced visualization, advanced functional programming. And this is where you learn the awesome packages like H2O, Lime, recipes for pre-processing data, Lime for explaining data, H2O for automated machine learning, and so on. You do that while you follow a business consulting framework, and that's what this is here. It takes about 10 weeks to complete, and out of it, you get the inputs that go into the next course that we're currently developing. So the 300 series course is the capstone. This is where you are now taking all that stuff that you've learned through the foundations and the intermediate to advanced course and actually converting that into a Shiny web app that encapsulates H2O, Lime, and so on. So in this course, we've actually redesigned how we're developing it because of this new technology that just came out of the RStudio conference. So we're integrating, we already were integrating HTML and CSS as part of it. So we're going to teach you that, and we're going to teach you Shiny, but we're also going to teach you some of these new packages like Shinytest, Shinyloadtest, and Profvis for actually testing out that application and making sure that your application is as close to production quality as you want to take it. You'll build this app, the app that we saw, and it's going to take you about 6 weeks. So that's the plan. And here's the result. In about 23 weeks, you can go from square one to literally deploying web apps within a business. And you can't do that anywhere else. If you do that in a university, it'll take you probably 4 years to get this knowledge. So that's really the grand scheme, the thing that we've been working so hard to build at Business Science University. And we want to share it with you. We want to teach you and take you from wherever you are, whether you're beginner or intermediate, to building and deploying applications so you can generate business value for your organizations.
It definitely sounds like a lot, guys, but once you jump into this stuff, it's not as daunting as it may look.
Yeah, and
the goal here is to just lay it all out on the table for you so you understand everything that's involved.
Yeah, and the other thing is that through the university program and through showing you those graphics, we want you to understand that we've got a plan for you that's going to take you through exactly what you need to learn and nothing more, so that way it's as efficient as possible. Really, we put a lot of work into developing these courses with efficiency in mind, and that's why it only takes 23 weeks, which is a lot shorter, and that's through 3 different courses too. So you take them in bite-sized chunks, do a little bit each week, 5 to 10 hours each week, and before you know it, in less than 6 months, you've got pretty much the equivalent of a university degree, and you're for a lot less money too. So I do want to extend this promotional offer to you. If you use the promo code Learning Labs, plural, all one word, you'll get 15% off of the courses. And right now we have currently available the 101 course and the 201 course. And then we also have a bundle if you want to grab the 101 and 201. We don't have the 301 developed quite yet because of some of the changes that we just found out about with our studio conference with load testing. So we're going to integrate all of that. And don't worry though, by the time you guys finish up these courses, that 301 course will be ready for you. So that's pretty much it. So just remember Learning Labs, and I hope you enjoyed this Learning Lab.
Yeah, it's really cool. So a bunch of questions here. Let's see, we have 8 that are open, but I think some of them overlap. So let's just do a quick fire, and I'll read off the question and either answer it or pass it off to Matt.
Okay.
So Matt, do you teach HTML and CSS as part of your course? This is from Jennifer Cooper.
Yeah. So for the course on the web application development, so this 300 series course, we're going to have HTML and CSS be integrated into the course. It's going to teach you. I mean, it really will be a full scale course. I assume you don't have any HTML knowledge or CSS knowledge.
All right. Does Python have something like Shiny?
Yeah, Python does have Dash, and actually I'm getting familiar with that because this Friday I leave for London, and I'm going to be doing a workshop with one of my key clients, and I'm teaching them both Shiny and Dash.
Awesome. Okay, let's see. What is the difference between Shiny and visualization tools such as Tableau or Looker? Which can you use to deploy and visualize results from analysis?
So the tough part with Tableau is predictions. So if you're looking at integrating, H2O into like an automated machine learning model into your application, that's very tough with Tableau. And the problem is that Tableau is very descriptive. It does great with nice visualizations, but from my personal experience, and David, I don't know if you feel the same way, dashboards just don't affect the business as the way full-scale applications do.
Yes.
So when you deliver a full-scale application that has like you saw how that application had the risk associated with that person, it had some what are the key features that you need to look out for, and then also gave some recommendation strategies. That's all the information that manager needs to be able to prevent that employee from leaving or do his or her best effort at it. So you can't affect decision making when you can't tell them, what the risk is, when you can't tell them which features are problematic, and when you can't make recommendations.
Yeah. Okay, you'll like this one, Matt. Do you have experience building a GPU rig to take advantage of H2O GPU or CUDA-based processing for R?
Yeah. So so I'm actually teaching at NVIDIA GTC conference in March. We're doing a lab with them. It'll be like a 2-hour lab on finance. But basically what we do is we use a lot of XGBoost with NVIDIA. Also, there's the H204 GPU. I haven't used a whole lot of H204 GPU just because I've primarily done XGBoost. But, also for deep learning as well, we use that quite extensively. We have a $200,000 supercomputer that Business Science has access to. And we can do we can go, sky's the limit. Just for example, we did a model on 500,000 loan observations, or actually, I think it was 20 years times 500. Yeah, it's a lot of data. It crunched the numbers in like 45 seconds, which is just insane. We had to distribute it to 8 different cores, but when we did that, it went from 8 minutes down to 45 seconds.
Yeah, you had a pretty cool picture of this massive machine. I'm like, man,
yeah,
that thing is a powerhouse. It looked like one of the old school mainframes.
It's like a spaceship. Yeah.
Yeah, it's pretty cool. Okay, let's just do a couple more because I know folks really want their questions to get answered.
Sure.
Shravan, if you're still on, this was asked a while ago. How efficient is our Shiny app when the millions of data is connected to a data lake? Can this our Shiny web app dynamically update with a quick turnaround?
So this goes back to efficiency. Typically what you want to do, and dplyr actually makes this really easy. It has a SQL backend to it, so it can actually push the calculations from your local machine, which is not going to be high powered, to your database, your data lake, which will have much higher power. So for example, if say you use Google BigQuery for a lot of your data analysis, I was just in a training session with Edgar at our studio, and he showed me how you can do all of your calculations using Google BigQuery's machine, which is much, much faster than your machine is. And you can literally crunch he had like 500 million data points, and he was plotting them very quickly, and it looked like almost like a real-time app.
Very nice. Okay. Is H2O the best production ready ML package in R? What about ML, R, and Carrot?
Yeah, so Carrot's, I would say, time tested. It's getting a little bit dated though, although Max Kuhn at our studio is keeping it up to date. He's actually coming out with Parsnip now, which I don't know if you saw that in one of the slides, but Parsnip is going to replace Carrot, but that's currently under development. There's also the MLR package. I actually don't have a whole lot of experience with the MLR package. H2O, in my mind, is it's highly scalable. It's coded in Java, so it's extremely fast, and it's basically made everything super simple for me to do. So if I use automated machine learning, I get my models, and then what I can actually do is then take the models that I like and actually drill into them and adjust the parameters and even try and eke out even more modeling performance out of those. So that's why I like H2O. It's fast and it does a really good job, and it's pretty much with the automated machine learning made it very quick and efficient to get good results.
Okay, so 2 more questions, and this one is an overlap because several people have asked similar questions, but how interactive are the courses? Can you describe how the students and teacher interact? How will I get help, etc.?
Sure. So what we do is we implement a Slack channel, which actually I know I can even pull it up here. So this is the Slack community channel, And this is basically what I'm in every day. For example, 9:22 this morning, this is yesterday, we were in here chatting. Somebody wanted to know, for example, with the Read Excel, how they can iterate through each of the different Excel sheets. I provided this response. It was something I was already working on and integrating into the course. So, but there's a lot of different, just dialogue in here. Each course lesson has its own community section. So you can see here, this one was yesterday at 3:55. Again, a Read Excel question, but so this is one chapter, two chapter, this is the third, and so on. And then the 201. So if you're in the R track, we're all in the same community channel, and we can all kind of interact with each other, and you can interact with me. So that's probably the easiest way to get help. Also, I'm available by email, where all of the instructors are available by email. And then in addition, there's a forum. So we really don't want to see, we want to see you guys progress. And ultimately, what we want to do and what we've done is we have the class sizes have been kind of at the right point where we're still able to provide 100% very fast responses and guidance and help you guys grow.
Yeah. And if you go to, there's a couple questions about the course structure. If you go to university, https://university.business-science.io, and you register, you can see the course outline. And then there's a few videos within the outline you can access for free, just to get a feel for what the courses are like.
Yeah, we can put it in the chat too.
Yeah, I put it in there. Let me do it again.
Okay.
Somebody just said the same thing. Like, why don't you just put it in the chat?
Yeah. And don't forget Learning Labs. This is a good discount code. We want you guys in there. This is it's a big thing to be able to take this education and get to where you want to go and achieve your goals. So we want to help you, and we're going to give you 15% off as well. Okay.
So much thanks for everybody for all the questions. I hope we were able to answer them. I know a lot were coming in, and I tried to write them down and take note, but this is the last one. And Jennifer Cooper asked, are there other R packages we should be aware of that do these things, or is this list of tools here exhaustive? So with all the tools out there, is this good enough, I guess, is the question.
Yeah, we've handpicked these tools. And Jennifer, thanks for hopping in here. I know Jennifer through Data Science Go conference and also through LinkedIn. So thanks for asking, and thanks for being on here. So yeah, what we've done is I've handpicked these because these are the tools that I actually use when I'm either doing my consulting projects or when I'm doing my workshops. This is what I teach. I teach it because I think it's the best. Of course, there's like 15,000 R packages, and there's certainly other ones that you can learn. There's other ones too that are like, I don't have listed on here. For example, down the road, our data table is probably one that you'll want to learn because it's super fast. It's all written in C, and it does like all of the dplyr operations in kind of a different style of code, but it's amazingly fast, and it's way faster than dplyr. It's way faster than Python. It's way faster than, it's pretty much approaches the same speed as C or C++. So that's one that you might want to learn. But at the end of the day, we can't learn everything. We need to be focused. And these are the packages that I feel are the best suited to get you to go from the foundations to machine learning and then ending with deployment.
Yep. So I think that might be it. Yeah, thanks everybody for tuning in. I hope you enjoyed the content. We definitely had a lot of fun putting it together and doing our second learning lab.
Yeah, and just real quick too, Fabio and Chris and Kerr have another Data Science Live going on tonight. I believe it's 8 or 9 p.m. and that's Central Time. So if you guys want to check that out, that's a good opportunity. They have Kurt DeBorn on there, who's just a famous data scientist. So you want to check that out. Contact Fabio or Kristen for more details.
All right. Sounds good.
All right. Thanks, guys.
All right. Thanks, everybody. We will send out an email with the slides and links to any resources, and then we'll let you know about the next episode.
Yep. Yeah, and we'll also publish the recording as well, so you'll get a copy of that.
All right. Take care, guys.
See ya.